All right. Good morning from my end. So we were able to successfully round up the classes for the Python basis, and that was last week. So this week we are resuming a new set of class. We are resuming the next month immediately. And for this month, we have here is a list of things we need to achieve this month. Okay, let me go through this routes. All right. All right. So for this week, it's gonna be more of pandas. So we're gonna the whole of this month we're gonna spend it on majorly Python library that will help us in data science, right? So for the first week, it's gonna be advanced pandas that has to do with data frames and data cleaning. Then the next week we'll go further to we'll go into NumPy, numerical Python. And then the third week we'll try to do some visualizations with Matplotlib with Seaborn and see how we can create relationships with those packages. And then on week 4, we're gonna do more of projects, right? There will be a mini project that has to do with exploratory data analysis. It has to do with more visualization. So hopefully, I'll get different data sets so that each day we'll be performing each of the stacks and see that we achieve them before the classes, before the time elapsed for that particular week. And in each of the week, we have 3 days, just like we agreed, or 3 videos coming up, right? So that's that. And so with respect to that, today we're gonna deal on introduction to Pandas data frame, right? Introduction towards Pandas data frame. And also we're gonna look at operations in database, right? Which has to do with sorting, filtering, and grouping. So those are the major things we're gonna look out for. So don't mind me, this topic was supposed to be introduction to Pandas data frame, and then inclusive of that sorting and all of that. But then let's shoot. So introduction to Pandas data frame. So what is a data frame? When we say data frame, what is a data frame? A data frame is a two-dimensional tabular structure in Pandas, right? So I think I should have rather talked of Pandas first. So Pandas is a library in Python that once helps you to manipulate your data, and then two, it also helps you in the analysis of your data. So when you deal with when you're using Pandas, you know that you're set out to more of manipulation of your data and trying to see how you can put your data in good shape or performing analysis with your data. So similar to spreadsheet or SQL tables, Pandas is a core data structure. It is one of the core data structures in Pandas, and it's used for data manipulation and analysis. So we are still dwelling on data frame. So data frame is similar to spreadsheet or SQL. And at the same time, it forms one of the core data structure in Pandas, and it's used for data manipulation and analysis. So when we talk of data manipulation, you just have to do it playing around with your data and trying to see how to tweak it um to look better, right? So from our first bullet points, we have creating data frame. How do we create this data frame? So we know that there are multiple ways we can create data frame, but the three basic ones are creating data frame from a dictionary list. Remember when I talked on dictionary, I stated that we will need to absolutely understand what dictionaries are and how to write them because we're definitely going to use them when it comes to what's Python, Pandas rather. Also, from a NumPy array, we can create what's Pandas data frame from a NumPy array, right? And we can as well create that from a CSV file. We can create from a CSV slash what Excel file. That one has to do with is an already existing file, and then you want to bring it up to Pandas. So the medium that can help you bring it up to Python rather is known as the data frame. So let's look at a code here on how to create data frame. So the first guy is from a dictionary list. So the first thing to do when you're creating from a dictionary list is that you import pandas as what PD, right? And then when you import pandas as PD, because it's an external library, that is why we have to do what to import it into pandas. And then from a dictionary of list, remember we said dictionary of what? Variables that has keys and values, pairs, right? I have my key to be the name, and there's a value for the name. We have another key here. We have another key here. And thereafter, we have you close your curly bracket now because once you open a bracket, a curly bracket, the second, it's the close and open is what comes up. All right, so we now say df, which is data frame, is equal to pd, the alias name of pandas that we imported, right? Pd dot data frame. So you're saying pandas, look, I need you to restructure this data into what? A data frame. So this open and close bracket is requesting for what? An argument. And that argument should be a dictionary, right? So it should always be what? It should be a dictionary. Why do we prefer dictionary here? Is because what your data frame will do, your data frame will consider each of your keys to become your column header, right? Your header here and there, right? So we have name, this guy is the name. We have the age, then we have the city, right? So Pandas automatically converts this data into what a data frame, right? So print data frame from dictionary. This one is just a dummy, just right up here. It's not relevant or it doesn't really matter. And then you have your DF displaying what the entirety of this guy. So we could decide to do away with this guy, right? Uh yeah, I think we can. Okay. So let's do that very quickly and what will what will become of our code. And let's run this. It has to take a little bit of time because all right. So we have it here that I said print DF. And remind you, DF is what? The data in a data frame, right? So for it to be in a data frame, it has to be in form of rows and columns, right? So the name column, the age column, and the city column. So that's basically what I was talking about, that it looks pretty similar to that of uh God, guys, don't mind me, my keyboard has been really hectic and I've not seen a replacement for it yet. All right, so we'll bring back our code to normal. And then we have another one here, creating data frame from a NumPy array. So when you want to create data frame from a NumPy array, we have that you import NumPy as NP, right? And then we are having array to be equal to what? NP dot array. So you're basically doing what now? You're giving, you're creating an array, right? So this is how to create an array. And what do we mean by the word array, for crying out loud? So I would like us to see what an array is first. I know we'll do more of that. Okay, let's leave that for when we come to NumPy. I think we'll handle more of that. But for now, this is how to create an array. You import your NumPy first as NP. Why we do as is so as to reduce the characters we're going to experience, right? Or we're going to use. So we have NP here representing NumPy dot array. That means you're creating an array. And then this is a two-dimensional array where you have the first the first row, the second row, and the third row, right? And then there are just two columns. That's why it's a two-dimensional array. So I'm creating a data frame from that. I have what? df from underscore array. And mind you, because I'm creating a data frame, I'm make use of what? PD dot data frame, open a bracket, array, comma, columns is equal to dots, right? So why did we choose to put columns here? Is because we don't have the keys and the value pairs in an array. So an array will only give you what? Yeah, despite the fact that array will give you a two-dimensional can give you a two-dimensional data. It can give you a three-dimensional data, but it doesn't give you that benefit of having having your, how do they call this guy now? Yeah, your column header displayed. So that's why we come here. We now give it columns, right? So comma columns is equal to column one, column two. So because you already know it's going to be a two-dimensional array, or an array that has two columns, so you give it up here, two columns, and then you print data frame from numpy array. You having this guy here. So let's run this guy. You realize we have data frame from array. Um, then this is the display of the data frame. All right, so we said that there are three major ways, right? Although there are other ways. So now this uh, uh, how do we call it right now? Creating data frame from a file, an already existing file. So this one, we don't have to be the one to create the file. So right now I have a file here known as iris dot CSV. So this iris.csv is actually a data of a CL of an iris plant that was taken. So I think it's in the open repo. When you check on cargo, you're gonna see that. And then we have how do we now access this data? Yeah, right. How can we bring it up to our data frame? So we have a variable name known as data frame df underscore from underscore CSV. So that's just a variable name. So why it's like that is so that you know that your data frame is coming from what, a CSV file. And then we have PD, remind you, because we are working with data, that's always be what's pandas being represented by PD. Read underscore CSV, right? So before you can create a data frame from a file, an already existing file, there are a few things you need to do. Number one is that you must know the file extension name. Is it file? Is it an Excel file? Is it a JSON file? Is it there's one more. I think sometimes we have last file and all of that. So when you know what kind of file you want to create your data frame from, it will help you. So if you're having Excel, it will now be what? Read underscore uh Excel, right? So let's try to do something right now. Uh, okay, let me go back. Let me erase and see. Let's see what happens. All right. So I have this guy. I hope this plays out well. Okay, having difficulty bringing it up. Okay, so okay, let's continue with what we were saying rather. When it comes up, we will divert and brush that up. All right, so I was talking about df from CSV. So pd dot read underscore CSV, right? Once we have this guy in place, we'll now be having what? Iris dot CSV, which is the file name. So if you come here, you see that it's what? Iris dot CSV. So how do I do to always ensure I copy the exact name? I come here, I check this box, and then I click on rename. Owing to the fact I want to rename, so I can highlight and copy everything that is there, right? So let's come back we'll now be having what iris dot csv, and then print data frame from CSV new line will be equals to what df underscore from underscore CSV. All right, so what this will do for us is that, see, it displays this guy. Here are the column headers. So we have the sepal length, sepal width, and then the petal length, petal width, and the class, right? So it's as simple as that. We've talked of how to create data frame from three different sources. Now, so let's try to explain what data frame properties are. So there are some useful attributes of a data frame. Number one is the df dot shape. DF denotes data frame. So you might be seeing it more often than usual from now onward, right? So what does df.shape do? It returns the shape of the data frame, having the rows to come up first and then the columns next, right? Separated by a comma. Then df.columns will return what? Will return the column names, right? So it will just return, let's also refer to it as the header. And then we also have df.types or d types. So this guy returns data types of columns. Then we also have df.head open and close. So it just displays the first five rows, right? So it displays the first five row when you have a dot head. And there's one other one. I know there are a lot of them, but because of time to be able to factor this guy into this time, we are already 30 minutes beyond this video already. So it displays we have df.tail that displays the last five rows as well. So let's try to experiment some of this guy. Say df.shape, right? Okay, let's run this. Sorry about that, please. We also columns in data frame. So bring this guy, tell you what that the columns in data frame is what age and city, name, age, and what city. And then we can also have to know the data types, right? So let's run this to tell you that for name, the data type is an object. So when you see objects on as a data type, it usually refers to as strings, right? And there might be letters or combination of letters and numbers, or alphabet and numbers rather. And then for age, we have this guy. Sorry, we are having it to be integer. Now, of course, the age is supposed to be integer, right? It's a whole number, not a fraction. And then city is an object, right? So it has to be a name of a place. So D type is object. D type tells you what that the majority of the things there are what objects. So just in case you want to begin to analyze, you have to factor that into your analysis. And most times when you're looking ahead to perform some machine learning tasks on it, it will also guide you, right? Then let's look at we said df.head will give us the first 5 rows. So when we run this guy, we are having 1, 2, 3, 4, right? So why is this guy giving us just 4? Reason is that we don't have enough data in that data set. So we have just 3 rows of data. So, but then we can make use of this iris. That's let's try to see how this iris will be. So we are creating a new cell, and then we have it here to be df from CSV dot head, right? So if I run this guy, df from CSV has not been defined. df underscore from CSV has not been defined. So I didn't run this cell. Pardon me for that. All right, so let's redo this guy. All right, so you now see that you're having the first 5 rows, right? 1, 2, 3, 4, 5. And it's now being structured properly, better than the way you saw it previously, right? So that's basically what this guy does for us. So the second part of today's class will be more of looking at indexing and slicing. Indexing and slicing, right? So indexing and slicing allows you to access specific rows, columns, or elements in a data frame. So indexing allows you to do what? Access specific rows, columns, or elements in a data frame. How do we go about this? The first guy, which is selecting columns. So we have columns can be selected using what? One, the dots notation and the brackets notation. So how do we do that? We have df dot column name, or the other way around, working with the bracket notation. We have df open and close square brackets, and then the column name inside of it. So, having done that, let's look at let's print a single column, right? So print name of column, and then what is inside of that column should be displayed, of course. So we have df by way of using bracket notation. Then the column name, which is name, when we run this, we realize the first name there was what? Alice. Then we are having Bob, and we have Charles, or rather Charlie, right? So then the other way around, we can have multiple columns. So when we are having multiple columns, it means you bring your column guy, you put them inside a list. When you have more than one, your column name should be in a list. So it's a figure, it's a factor into rather, it's to tell your data frame that look, I need more than one column name to be displayed. So if I run this guy, should be having what? Name, then this, and this, right? So let's try selecting of rows. We've done selecting of what? Columns. So let's try selecting of rows. Rows can be selected using ilog. What is the meaning of ilog? Ilog are index-based selection. Index ilog, index locator. log is just label locator. All right. I know someone will be expecting L log, but it doesn't work that way. The conventional way is ILOC for index-based selection, and then LOC for label-based collection, right? So let's try to see how we can make use of that. We have df dot ilog 0. So I want to select a single row by index, right? So let's do that. We run this guy. If you notice, we're having just what? A single row for the entire df. So for the name is the first name that would display, which is what? Alice. And then, so before then, let's try to bring this df down. It will help us to see what we are saying in order for us to, in order for it to establish our arguments, right? All right, so we have the first role in our name, guys, to cooperate is what? Alice, right? Then we have age, which is 25. What city? It's actually what? New York City. All right, so when you run this guy, I've run it already, so it will give you this. Then let's try to see how to select multiple rows. So mind you, I have to touch this guy. This guy is known as indexing, right? So I use the index value. So if you look at this guy on the left here is the index number. So he 0 stands for the first row, 1 stands for the second row, just like we did during indexing of lists. So it's similar. And then we can select multiple rows. So it's in form of slicing. So these multiple rows are what? Slicing, right? Then in doing this, we have df.ilog start point should be 0 and it ends in 2. So but the last one, which is that 2, will not display. The index value of 2 will not display, so it will only show you the first row and what's the second row. So let's run this guy. You're having the first row and the second row. So how do we now select rows based on some condition? So we need rows where age is greater than 25. So this is important when you're dealing with what? When you're trying to understand or filter your data. So we give you the condition. We say df age is what's greater than 25. So this one, you're filtering, or rather, yeah, it's part of filtering. You're filtering this data with respect to age. So you want to display you want to display the data with the variable age that is being greater than what? 25, right? So what it will do for us is that it will take out um the row which has its age less than 25. So let's see. We are now having Bob being 30 years and lives in Los Angeles. Charlie here is 35 years and he lives in Chicago. So you realize it has actually removed this girl, Alice. The lady Alice has been um dropped because it's below. She is exactly what? 25, but we need people that are more than 25 years old. So we didn't include the condition that will accommodate her being equal to, right? We needed people beyond that's um greater than 25, right? So this give us what we want. So if we run this code, we should be having this guy here. So the other operations like on data frame, which has to do with sorting, right? So data frame can be sorted by one or more columns using sort underscore values. All right, so sorting has to do with arranging your data in either an ascending order or a descending order, or with respect to a particular condition you're going to give to your data, right? So here we have df.sort underscore values age, right? So we're sorting with respect to age to arrange the age in order of what? Increasing order, in increasing order. So I have age 25, 30, 35, right? So running this guy to give us this. And then we can sort by what? Sort by multiple columns. So now I use this particular cell to attack two things or to solve two problems rather, not attack this. The first is how to add a new column, right? Adding a new column. It's simple. You you type your data name, which is df for this case. Um Then there's a square bracket. So we are using the bracket notation here. The square bracket and what you want the variable name to be. So what's it then this side will now be the items that should be on this particular column. So your df, you know automatically that what is coming up here is what is a new variable name, rather a new column name, please. And then these are the assigned values that are going in for this guy. So if I want to sort by age and by score, I have what dot sort values. What are the columns? The first is age and the second is what? Score. And then do we want this guy to be in ascending order? Yes, we want the first one. Mind you, with respect to index, we want the first one that is having the index 0, which is age, the one that aligns or corresponds with this. We want that one to be true. And then we want the one of score to be what? False. So we don't want these guys to be in ascending order, right? Then when you run this guy, you realize you're having this your man to be 25, sorry, the lady be 25, 30, 35, right? And then the scores are not even arranged. So that is what it is. So the next is filtering. Filtering extracts rows based on conditions, just like I explained. So I wouldn't want to dwell much on here. So I just repeated the same code just for purpose of documentation, right? If you run this, it should be giving you this. And then there's another condition that when the city is equal to Chicago. So, right. So what filtering helps you to do is it helps you to understand your data more. So probably you have a large data set. Why this is looking pretty simple here is because it's looking more or less irrelevant is because we just have 3 rows or 4 rows of data and you can easily see your data and access them physically. But there are some times where you have data set that has to do with millions of rows, right? Or data points, you may not be able to have access to all of them. So using some conditions like this will help limit the display and at the same time limit the number of data points that you should be experiencing because you've placed a condition somewhere, right? Then running this guy, you will be having city is Chicago, so it's just one guy that lives in Chicago, which is Charlie. And then we can perform grouping, right? So grouping aggregates data based on values. So the most common method is group by. So we'll make use of the group by. So let's group by city and calculate the average age. So we want to calculate the average age. We want to group by city and calculate the average age. So group by means you're bringing you're bringing the entire, okay, let's continue. I'll explain that. We have a variable name here known as grouped, right? And then equals to df is our data frame grouped by, you're grouping this data frame by this variable, right? So what it will do for us is this variable being city, you're now telling it, okay, rearrange the variable with respect to the city values. So those that are staying in Chicago, we need them to be in one group. Those that are staying in Los Angeles, we need them in one group, and New York, we need them in one group. And then how would you want their values to be displayed? So that's why we have age here. So we have age being what? Age in this square bracket dot mean open and close. So we are looking for the average age of people that lives in Chicago. So this will look more interesting when we have a larger data set, such that we probably will have up to 100 people living in Chicago, and they have different ranges of ages. So we can, as always, look for their average age. So we can literally say that, okay, after analyzing this data, we have those that are staying in Los Angeles, the average age is, let me say, around 25 years or 30 years, as the case may be. So that is what this guy does for us. We can group by city and aggregate multiple metrics, right? We can aggregate as much metrics as we can. So the first is mind you, we are still grouping by city, and then dot aggregate. What are we aggregating? The age. We need the mean of the age, and then we need the marks of what's the score. So this is how it should be displayed, right? And then print aggregate by this guy is just what you should do. So that is the basis we need to understand about data frame and how to perform one or two manipulations there. So we have a hands-on practical section. The task is to create a data frame with the following data. So this is the following data we need to do. So mind you, when you're creating your products will be a value, sorry, a key, category will be a key, price will be a key, and quantity will be a key. And all of that, these guys, you have your laptop, desk, phone, and desk to be the values on the products and the same thing. So the task we are saddled with is select the price column, right? Filter the products with price greater than 500, and then group by category and calculate the total number of quantity. So I've been able to create what the data frame for you. So your task will now be what to select price, right? So this is the data frame here now. Products, category, price, and quantity. So what you're saddled with is what you have to select the price column. We need just the price column, and then the filter products based on price being equal to 500 naira. So, sorry, 500, and then group by category and calculate what's the total quantity. All right. So it's pretty cool. It's nice having you till this time. So this is the first class. So before still this week, we're gonna roll out other videos. I will have to do with handling of missing values. Then we go into further advanced operations that has to do with merging, joining, and concatenation. So today that ends the class for today. Thank you so much for being present.